Hello guys, in this video I'll be discussing the question L-shaped plots from the round A of Kickstart 2021. So the problem is as such: given a grid R rows and C columns, each cell in the grid is either 0 or 1. A segment is a non-empty sequence of consecutive cells such that all the cells are in the same row or in the same column. Okay, so basically we are given a grid and we have to consider a segment, and a segment is like a sequence of consecutive cells, and it should be in the same row or in the same column. We define the length of the segment as the number of cells in the sequence. A segment is called good if all the cells in that segment contain only ones. An L shape is defined as an unordered pair of segments which has the following properties. Each of the segments must be a good segment. So basically we know that a good segment is a segment in which all the cells contains only ones, and an L shape is basically an unordered pair of segments, and it should have the following properties. Each of the two segments forming the L shape should be a good segment, that is, all of them should have a value 1, and they must be perpendicular to each other as shown in this, and the segment must share one cell that is an endpoint of both the segments. There should be a shared cell, and that shared cell should be the endpoint of that one endpoint of both the segments, and the segments must have length of at least 2, and the length of the longer segment is twice the length of the shorter segment. So if the length of the shorter segment is 2, then the length of the longer segment would be 4, and if it's 3, then 3 6, 4 8, 5 10. So this is the valid pair of shorter segment and the larger segment respectively. So below you can find the correct L shapes. So we can see here is that this is let's come to this one. This is not a valid L shape because we can see that the end point is not the end point is of the shared cell is not the end point of both of these segments, so this is not valid. In this case, the criteria of that the size of the longer segment should be twice of that of the shorter segment is not valid here. Following here, so this is also not valid, and similarly this one too. So now let's discuss let's go through the solution now and talk about how we can solve this question. So basically we are given a matrix here, and which has some rows and some columns, and we have to find the valid L shapes, the total number of valid L shapes in this matrix. So we can have L shapes like this, or like this, or like this, or like this. So there can be a lot of L shapes, and and also all the cells in that L shape should be 1. So we can have a lot of L shapes like that, and out of those only valid are to be considered, and all the valid ones are such that the length of the shorter segment into 2 must be equal to the length of the longer segment. So let's take an example test case from the question first. Let's say we have an let's consider the second test case in this question. Okay, so we can see that in the second question we are given number of rows as 6 and number of columns as 4, and the values are as such. So this is the values if given the matrix, and we have to find the total number of valid L's here. So let's just say that we take this L here. So what happens, that this is a valid L because we can see that the shorter segment's length is 3 and the larger segment's length is 6, so that's valid. So we can say that this is a valid L. And what if we take this L here? So what if we take this L here, this 2 and here 4? So this is also a valid because 2, 4 is a valid combination also, right? So 3, 6 was the first combination and 2, 4 is the second combination. So since both of these are valid, so in this particular combination we have got 2 valid L here, L shapes. So similarly there can be a lot of more L shapes, like this is also a valid L shape because it's also 2, 4. This is also a kind of 2, 4, and this is also a valid L shape because this is also 2, 4. So now what I want to say, the solution which I am proposing here is that we will look from the viewpoint of the shared cell in one L shape. Let's say this is an L shape here, and this cell is the shared cell between the two segments forming the L shape, and I will mention this as shared cell in the rest of my solution. Okay, so like if this is a shared cell, what we can say here is that each of these cells in this matrix which have a value 1 can be a shared cell, and we can, like, if suppose if this is 1 here and this is a shared cell, let's suppose any cell in this matrix containing 1, which can be any of the cells, so we can have like L shapes like this in of this shape, or we can have L shapes of this shape, we can have L shapes of like this shape, and we can have an L shape of like this shape also, this shape, this shape, this shape, and this shape. There are basically 4 different possibilities if we take this as like the shared cell. So let's talk more deeply about this. Let's suppose there is a arrangement of cells in this way, and this is the shared cell. So like, and these all cells which are alongside this shared cell, we contains the 1 in their cells. Okay, so how from this shared cell we can go either in this right direction to form a segment, either we can go to the top direction to form like up direction basically, or top direction to form a segment, we can go down, or we can go left. And out of these 4 directions we can have like 4 valid combinations of take 4 valid combination of these 4 directions, taking 2 directions at a time, that could give me an L shape, and possibly valid L shape depending on the size of those segments. So basically, let's say if these 4 other directions, we can get an L shape if we consider top and right. We can get an L shape if we consider top and left, or down and right, and down and left. So like these are the 4 different possibilities if we take a particular shared cell, and in these 2 possibilities we can get as many number of L shapes. Like suppose if we just consider this here, and let's just increase the number of cells here, and you will get to know why I'm doing this. So let's say we are just considering this case here first. So what happens here is that top and right, we are just considering this shape of L. Okay, and in this we have to we can have many number of x number of valid L shapes, as suppose we can have like 2 from here and 4 from here. This can be a valid L shape. Okay, or this, if we take 3 from here and 6 from here, 1 2 3 4 5 6, this also can be a valid L shape. So basically in this thing we have in this shape of L, in this particular combination, we got 2 valid L shapes. Okay, so similarly and this all 3 cases are similar. If we are able to solve one for one case, we will be able to solve for all these 3 sub cases eventually. So in the further solution we will be discussing this, and from that you will be able to figure out all these 3 by your own self, and let's move forward now. Okay, so now in order to, like, the question here arises that in this case I have already assumed that I know the total number of ones in each of these directions from this shared cell, but in the matrix, in the given question, we are just given a matrix which contains whose cells contains ones or zeros. So but how are we going to get information something like this, where for each shared cell we have the total number of ones on in the direction above that, the total number of ones in the direction below that, and the total number of ones in the direction to the right of that, and the total number of ones to the direction left of that. So and by the total number of ones here, I am talking about the total number of consecutive ones including that particular shared cell. Okay, so if we are able to get that information, if we are able to get the total number of ones in each of these directions, then we will be easily be able to solve the question. Like let's say, like, if you have, like, there is a shared cell here, and I know that this is 1, this should be 1 always, and suppose we have 5 ones in the direction above including this particular one, and we have 6 to the right, we have 4 to the left, and we have 2 to the bottom. So how can we how can we, let's just say we are just considering this particular case here. Okay, we are just considering right and top here. So we can say that let's call it u, and let's call this v. So u is equal to 5 here and v is equal to 6. Okay, and u will always be the minimum of right and top, and v will be the maximum of right and top. Okay, so because when we will be talking about the rest 3 conditions, similarly there will be a few changes, like right will be changed. Suppose we are taking right and down, so this will be right and down, this also will be right and down. So this you can figure out by yourself. Okay, so like suppose this is u and this is v. Now if I talk about like how many, like if we have let's make these 2 segments separately. Suppose this is one segment of length 5, 2, 3, 4 and 5, and this is one segment of length 6, 3, 4, 5 and 6. Okay, one second. Okay, so this is u and this is v. Now like when we have 2 segments, and this is the shared cell in there, okay, and this is the shared cell. Okay, now in these 2 segments, when we are forming an L, and this L is of varying size here, okay, varying shape and varying size, okay, so with these 2 segments we can have multiple combinations, like we can have like the smaller we can take the smaller segment from this the u, and we can take the larger segment from v. Like this part comes from this and this part comes from this. This is possible, or vice versa. We can take the smaller part from this and we can take the larger part from this. Now you'll say how? So let's say we take 2 cells from here and we take 4 cells from here. So we will get an L something like this of 2 sides here and 4 sides here. So 4 sides here. So this is a valid L shape, and the smaller one comes from V and the larger one comes from U. So like now for this subcase, we have 2 more nested subcases in which the larger segment can come from one and the shorter segment from other, and vice versa. So now we'll talk more about it. Like let's say we have u as 5 and v as 6. Now let's say that the shorter segment comes from u, from the shorter segment. Okay, by shorter segment I mean the shorter segment of the L shape. Okay, suppose this comes from u. Yeah, so how many valid number of segments, how many valid length of shorter segments can come from u? As we know that we can have either 2, we can have 3, we can have 4, or we can have 5. Okay, so what we can say here is that the total number of valid small segments size could be how much? U minus 1. Since like we have 5, so we can have 2, 3, 4, 5. If we have 7, we can have 6. Basically it's just we cannot have 1 and we can have all the values other than that. So this is the total number of valid small segments size. And now what will be the total number of valid large segment size if we have v is equal to 6? The total number of valid large segment size would be valid large segment size would be v by 2. Okay, so v by 2 is how much? 6 by 2 is equal to 3, which means like we can have 2, 4 and 6, and we know that we cannot have a larger segment as size 2, because like if this is 2, this is the minimum possible size of the smaller segment, and we know that the larger segment size should always be should be twice as the shorter segment. Okay, so we cannot have the larger segment size as 2. It should always be greater than or equal to 4. So like if we say that v by 2 minus 1 is the total number of valid larger segment size from this V, then we will get something like this. Okay, so out of this possibilities, like let's see now, from U the total the valid cases were 2, 3, 4 and 5. These were the valid cases for the smaller segment size, and from V the total number of valid cases for the larger segment size were 4 and 6, because we neglected this by doing -1 here. Okay, so out of this now, so what is the total number of valid L shapes here? We can see this and this. So we can say that for this one sub case in which we are taking the smaller segment from U and the larger segment from V, we can have valid L shapes as minimum of U minus 1 or V by 2 minus 1. So what will be the minimum value? We will get the total, that will be the valid number of L shapes for that particular sub case. Now similarly you can think of like if you have U, if you take the larger segment from U and if you take the smaller segment from V, so the total number of valid L shapes, let's call it dash here, that would be minimum of since we are taking the smaller segments from V, it would be V minus 1. We can have 5 possibilities here. We can have 5 possibilities here, like 2, 3, 4, 5 and 6, and from U we will take the larger segment, and from here we can have how many possibilities? It would be 5 by 2 minus 1, which is 2 minus 1, that's only 1, that is we can just have 4 here. So what will be the answer? 2, 4. So my answer would be here U by 2 minus 1, this, and if we add both of this will give me the valid total number of valid L shapes for one of the sub cases in this thing. Like for one of the sub cases in this, we'll get this, we'll get suppose the total answer is something from this plus this plus this plus this, so that would give me the value here, and when we'll solve for this, this and this respectively, we'll get the answer. So yeah, okay, so this is how we can calculate the total number of valid L shapes for each of these directions and get the total answer. But the question here still arises that how do we get the total number of ones in each direction from that particular shared cell? So for that I used a dynamic programming approach, and using that I created 2 matrices. Like one matrix was like contained the information for each shared cell and the total number of ones in the in the bottom, in the direction below to that shared cell and to the right of that cell, and the other matrix contained information of the total number of ones in the direction above, that is top and left. So and each of this cells was a pair, and the first and the second number of this pair represented the bottom number of ones, consecutive ones, and the right number of the number of ones, consecutive ones to the right respectively, and similarly for this. So I will be discussing the dynamic programming approach now, and if you are able to if you're able to think, if you would like to do this by yourself, if you want to try to implement this dynamic programming approach by yourself, so please go ahead and try it yourself, and if you're able to do so, proceed with the logic which I just discussed and try to solve this question by your own. If you're not, now I will be discussing the dynamic programming approach here. So basically we know that we have a matrix here, okay, and we have values like 1 0 1 0 1 0, something like this, let's say anything, okay. So for each of this ones here and zeros, we need information of how many consecutive ones to the right, left, top and bottom are there, so that we can implement so that after we have calculated all these values, we can just traverse each cell of that matrix, and for each cell where we have a 1, that can be a shared cell in a particular L, and for that shared cell we can basically consider all the four possibilities, which is the combination of the directions, taking 2 at a time, and for each of these possibilities we can take out the maximum number of L shapes using the formula using the formula we discussed here. So this is how we are going to approach. And now how do we create these two matrices here? So basically, now when we are on 1 here, when we are on this cell here which has a value 1, either we can go to the right or we can go to the left. Now when we go to the right, we are basically calculating the total number of consecutive ones to the right of this cell, and when we go to the down, we are basically calculating the total number of consecutive ones to the down of this cell. So but when I come to this one, how do I know that how do I know that for this recursive call I have to return the total number of ones to the right of the cell, not to the bottom of the cell? For that I will use a flag, let's say is horizontal. So when I'm calling this function here, let's say I will be just talking about this case here, and this is very similar to this, so you can easily understand that and figure it out on your own using what we have discussed in this case. And even if you are not able to understand, I will discuss the entire code at the last of this video, and using that you can correct your mistakes. So I have used a flag here is horizontal. When I will be called suppose there is a function recursion, in that I will pass the values I, j, and a flag true. Suppose if it is true, then this tells me that I have at the end of this recursive function I have to return the value, the total number of ones to the right of that cells, including the current one. Okay, and so this is, and if it's false, I have to return the total number of consecutive ones to the bottom of the cell, including the current cell. Okay, so like I will like to discuss this approach of mine through code, and like how I've implemented in code. That will be easier, and I'll be coming back to the explanation in case we have some difficulties there. This is my code for this particular problem, and like first of all we are solving for each test case here, and like this is the method which will be implemented for each test case. Okay, so the RNC, I have initialized RNC and the vector grid and the matrix down, right, and top and left as global, because I will be using this inside function. So global scope was easier because I don't have to pass the matrix to these functions again and again. So this is here I have taken the input for the rows and columns. Here I have initialized the size of that grid. I have taken the input of the grid here, and yeah, this is here I have initialized the down, right, and the top and left 2D matrix here, in which each of the cell is a pair, and in which the first part of the pair is representing down and right and top and left in these 2D matrices respectively. And firstly, this is a function which will call this is the function which will be implemented to find all the values, all the total number of consecutive ones for each cell to the down and right. And this is so first of all we will discuss this function here. Yeah, so this is the function here in which I am taking the value I and j as I talked about here in this function. And initially when I'm calling the function here, I'm setting this flag to true because that doesn't mean anything. That is redundant and it's useless for me. I can even set it to false, it doesn't matter. So like here, first of all I will just check here, like since I'm using dynamic programming approach and I don't want to end up in an exponential time complexity here, so this is why I will just check here that if the value of down, if the value of the first in the pair is not equal to -1, and if we like the first one is representing the value down. Okay, So the total number of ones to the down of the total number of consecutive ones to the down of that cell. Okay, so if it's the flag is not horizontal, it means that I have to return the total number of ones to the down of that cell, and so I will return it. So I'll return it here, and same is for this. If the flag is true, it means I have to give the total number of ones to the right of that cell, including that cell, and so I will return this here. And initially, and if these both these conditions are not met, it means that the value is not calculated yet. So what I'll do here is that first of all I will initialize both the values as the number value itself. Suppose the value was 0, the grid value was 0. So initially from -1 and -1, these both will be set to 0 here, which means that there are 0 ones and to the down and to the right. So if it's 0, then now if it's 0, what does that mean? If it's 0, then it means that what I can do here is that I will simply say that I don't have to increment. If it's 0, that then it means what? If it's 0, it means that I don't have to add, I don't have to put any values here. The value here will always be 0. The length of the total number of ones to the all these 4 directions will always be 0, because the cell value is itself 0. Because if this is 0, then we cannot have this as a shared cell. So this is why we will call the function here. If I plus 1 is less than r, we will call it further. We will will call the next recursion from here. Similarly for the direction, I plus 1 basically goes down, and j plus 1 goes to the right, and whatever value we'll get, we always pass 0. It means that when we go from this cell, when we go from, like, suppose when we are on this 0 here, this particular value was 0, and when we go from when the value will be returned from here, that will always be 0, because we only need consecutive ones. So we have just returned 0 here. And like if the value was if the grid's value is 1, then we will go into this loop here. First we'll call the right cell, and whatever value we get from the right, that the total number of consecutive ones from the right, we will add it to the current cell because it's 1. And similarly for this was down, and similarly for the right direction, and at the end we will just check the flag. Now when I come here, basically when I reach here, now we have set the value. We have set the values, the total number of consecutive ones to the down and to the right. And now when I come here, basically I just have to check, like for the previous call, whether we were going in the horizontal direction or we were going in the bottom direction. If it was in the bottom direction, then this flag would be false, and then we have to return the first value, which points to the like the down number of consecutive ones. Else we have to return the second value, which points to the right number of consecutive ones. So in this manner, the entire matrix will be created, and for each cell in the matrix we will have a corresponding value of consecutive ones to the right and to the bottom. Like if it's 0, then we will have 0 for both the values, for both the directions, and if it's 1, then we will have some non-zero value for both the directions. Similarly, we can see here, this is after setting it for the bottom and right. We are doing this for the top and left. Here what we have just changed is that we have made a few changes here. You can easily figure out if you go through the code. After that, when we have found all the values values for consecutive ones in all the directions for each cell, then we iterate through each cell of that matrix, and if the value is 1, it means that can be a shared cell in an L shape. And here we just store the values top, down, left and right from what we have calculated previously. And after that, here we will give a further check, like here, like if minimum of left comma top, which is basically if the minimum value is greater than equal to 2 and the maximum value is greater than equal to 4, then only we will enter this loop, then only we'll consider it for a valid L shape. Because if this is not so, then we don't have to consider this. Suppose if it's 2 comma 2, then no valid L shape can be created, right? So that is why we go further into which make a check here that the minimum value should be greater than equal to 2 and the maximum value should be greater than equal to 4. So here we take the value u comma v as we discussed in the solution. The u is first of all u is the minimum of the two values, two direction values, and v is the maximum of the two direction values. And now for total, what we do here is that we consider all for this sub case we consider both the sub cases. One is where we take the smaller number of the smaller segment from u and the larger segment from v, and this one is where we take the smaller segment from v and the larger segment from u. So when we take the smaller segment from u, we have u minus 1 possibilities to take smaller segments and v by 2 minus 1 possibilities to take the larger segments. And as we discussed, the minimum of these two values will give me a valid L shape, number of valid L shape for that particular subcase, and vice versa for like the subcase. So this is what we will do for all the directions: left top, left down, right top, and right down. And after that we will and at the end we will keep adding these values to the answer. And when we have traversed all the cells in that particular grid, at the end we will come out with the answer here, and this is our answer to the solution. Okay, so I understand this question was quite lengthy, and I hope I was able to explain it well. And like I hope you were able to understand the way I calculated this the values, the number of consecutive ones in all the four directions using dynamic programming. After that, how we have solved this problem for the four directions. So this was my solution in C++, and thank you so much for staying till here. And if you have some other methods, please share in comment box. And also if you have solved it in some other language and you feel to share it, please share it. That would help other viewers as well. And thank you so much. That's all from my side.